So for project 2, the objective is to use rotation matrices in Python for robotic manipulators. In this video, I'm going to demonstrate the concepts that are shown in the video and show how the Python code runs and change input angles live and then explain the results. So what a rotation matrix is basically a mathematic tool or a table that's like used to describe how an object rotates in space. The table itself is arranged in rows and columns, and it changes position of a point or object without changing like the size or the shape. So basically what it does is it tells you how to turn something around an axis, such as rotating the object left or right, or like a certain angle. Like sometimes it be in 2-dimensional or 3-dimensional space. The reason why that rotation matrices are important for like robotic manipulators is that it has the manipulators itself have multiple joints and links that move in different directions. So to control the exact position of it, engineers use rotation matrices to calculate each joint and how it should rotate. So the first thing we do is we need two variables that represent theta 1 and theta 2. So now we got theta 1 and theta 2 angles in degrees, and then we're going to convert those two into radians. And we're going to do it by 180, dividing both other angles by 180, and we're going to multiply it by numpy. But we're going to have to show numpy. When we import it, it is shown as 3.14. And numpy is used as a constant to make sure we don't have to write out 3.14 and all these other numbers over and over and over again. So numpy is used as a constant in this. So now I created a matrix right there, and at first I just wrote it out that way, but a better way to read it as more of a rotation matrix was this way. So now I defined my rotation matrices for R01, R12, and then for R02. The NP dot is basically multiplying to get R01 and R12. So now I'm gonna print it out. So then I ran the module afterwards, and this is the output that I got. So this output is telling us for the rotation matrix of R02 that the X2, Y2, and Z2 is this right here. So now I'm gonna do another test for this kinematic diagram where theta 1 angle is 90. This is what I get. We're gonna do another one where theta 1 is 0 and theta 2 is 90. So you ran it, and this is what we get. So basically, any theta angle that you put in and you run it is going to give you the outputs with the rotation matrix for X2, Y2, and Z2. This helps find out what direction that my end effector is, depending on any combination that I use.